Hello dear students, welcome back all of you to the physics online class. So in the previous video, we derived the expression for the conservation of the linear momentum. We have given a statement for that, and also we derived the expression that finally we proved that so the total linear momentum before the collision between two bodies is equal to total linear momentum after the collision. Yes, and that can also be given as total initial momentum of an isolated system is equal to the total linear momentum of an isolated system. So that is the final momentum of the system. Means initially how much the momentum was there, finally that is remaining constant. Or before the collision what momentum is there, after the collision also that remains the same. We have proved that. Right, and also we discussed about the applications of the law of conservation of the linear momentum, where that law is applicable actually. The first, it is applicable in the recoil of the gun. What is the meaning recoil? That means when a bullet is fired from the gun, the bullet will move forward and slightly gun moves backward, right? That is called recoil of the gun. And the velocity with which the gun moves backward is called the recoil velocity of the gun, right? And we have given the formula for that also. There the negative sign indicates how that the negative sign indicates that momentum, that is a bullet and the gun will move opposite to each other, right? Yes, and today we will move forward to study about the equilibrium of the body. The next point to be discussed here is equilibrium. What does it mean? Actually, equilibrium of a body due to concurrent forces we call here. Concurrent means what? The number of the forces which are acting at a same point, right? So if all the forces are acting at the same point, assume here is the point and here number of the forces are acting at this point, then it is called as the concurrent force. Okay, so then equilibrium means what happens? It is a state or the condition of the body or the particle, the state or the condition of the body or the particle which does not change the state of rest or uniform motion when force is applied. When a force is applied, then it is called body is in a equilibrium. ಅಂದ್ರೆ ಈ ಒಂದು ಬಾಡಿ ಅಥವಾ ಪಾರ್ಟಿಕಲ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂದಲ್ಲಿ ಐತಿ ಅಂತ ಅನ್ಬೇಕಾದ್ರೆ ಈ ಒಂದು ಪಾರ್ಟಿಕಲ್ಲು ತನ್ನ ಮೇಲೆ ಫೋರ್ಸ್ ಅನ್ನ ಆಕ್ಟ್ ಮಾಡಿದ ಮೇಲೇನೂ ಕೂಡ ತನ್ನ ಸ್ಥಿತಿಯಲ್ಲಿ ಯಾವುದೇ ರೀತಿ ಬದಲಾವಣೆಯನ್ನ ಮಾಡಬಾರದು. Am I clear? So it should not change the state of the rest or the uniform motion when external forces are acting on it. Then such a body is called the equilibrium. It is in a equilibrium. Am I clear? Then here we need to understand if the two forces are acting on the body, what will be the condition for the equilibrium of the concurrent force? ಒಂದು ವೇಳೆ ಒಂದು ಬಾಡಿ ಮೇಲೆ ಎರಡು ಫೋರ್ಸ್ಗಳು ಆಕ್ಟ್ ಆಗ್ತಾ ಇದ್ದು ಅಂದ್ರೆ ಹಾಗಿದ್ರೆ ಆ ಬಾಡಿ ಇಕ್ವಿಲಿಬ್ರಿಯಂದಲ್ಲಿ ಇರಬೇಕಾದ್ರೆ ಕಂಡೀಷನ್ ಏನಿರಬೇಕು? ವಾಟ್ ಕುಡ್ ಬಿ ದ ಕಂಡೀಷನ್? ರಿಮೆಂಬರ್ F1 and F2 be the two forces. Okay, therefore condition for equilibrium, in short I can write like this. Condition for equilibrium means when the two forces are acting on the body, remember the sum of that two concurrent forces should be is equal to 0 here. And if we apply this condition, then definitely F1 is equal to F2 will be the condition for the equilibrium of the body when two concurrent forces are acting here. Then tell me students, what the formula indicate here? ಈ ಒಂದು ಫಾರ್ಮುಲಾ ನಮ್ಗೆ ಏನ್ ಇಂಡಿಕೇಟ್ ಮಾಡತ್ರಿ ಅಪ್ಪಿ? ಯಾವಾಗ ಒಂದು ಬಾಡಿ ಮೇಲೆ ಎರಡು ಫೋರ್ಸ್ಗಳು ಆಕ್ಟ್ ಆಗಕತ್ತಾವು, ಆ ಬಾಡಿ ಇಕ್ವಿಲಿಬ್ರಿಯಂದಲ್ಲಿ ಇರಬೇಕಾದ್ರೆ ಒಂದು ಫೋರ್ಸ್ ಫಾರ್ವರ್ಡ್ ಆಕ್ಟ್ ಆದ್ರೆ ಇನ್ನೊಂದು ಫೋರ್ಸ್ ಹೆಂಗ್ ಇರ್ಬೇಕ್ರಿ? ಬ್ಯಾಕ್ವರ್ಡ್. ದಟ್ ಮೀನ್ಸ್ ಟೂ ಫೋರ್ಸಸ್ ಆರ್ ಆಕ್ಟಿಂಗ್ ಇನ್ ಅಪೋಸಿಟ್ ಡೈರೆಕ್ಷನ್ ಟು ಈಚ್ ಅದರ್. Therefore, I can represent that like this also. Consider it is a body. If force F1 is acting in this direction, then F2 will be acting in this direction. Because both the forces are same in the magnitude, but they are opposite in the direction. Am I clear? So this is a what? And when you take this and the total force is equal to 0, that will be the condition for the equilibrium of the body here. I hope the point is clear. Yes? And my second question, now two were there, okay, we satisfied this equation. Suppose three concurrent forces are acting on the body. Three concurrent forces are acting on the body. F1, F2 and F3. Three concurrent forces are acting on body, right? So what happens here? In order to understand the force acting on here and the equilibrium of the body, we may apply the law of the vector, triangle law of the vector addition, or the parallelogram law of the vector addition. When three forces are acting on the body, to bring the condition for the equilibrium, we can use the two laws here. One is the triangle law of vector addition, another one is the parallelogram law of the vector addition. Then if you consider the parallelogram law of vector addition, let us consider here three concurrent forces are acting. Here is a F1 and this is a F2 and here is a F3. Okay, then see here, it's opposite. This will be the sum of F1 plus F2. The force 3 means a third force, third concurrent force acting on the body will be balanced by the sum of the two concurrent forces. That means in this situation also there are three forces, F1 plus F2 plus F3 is equal to 0 here. Okay, then remember one thing, you want to write F3 is represented how? It is represented as minus of F1 plus F2. So this whole term, if I take this side, then it comes minus of, so F1 plus F2. This is a condition for the equilibrium of the body when the three concurrent forces are acting on it. Am I clear? So then what it is indicating? When the three forces are acting on the body, then the third force will be equal and opposite to the sum of the other two forces. Third force acting on the body will be is equal to equal and opposite here, equal and opposite to the sum of the two other forces here, right? So this is a what about the condition for the equilibrium of the body here. I hope the points are clear, dear students, right? And next, see, two forces are acting means we got the equation. 3 means like this. If more than three forces are acting, then here the polygon law of the vector addition will be involved to express that. So therefore, there in that already such a point we will learn even in where means I think in the case of study of the three laws for the vector addition, triangle law, parallelogram law and the polygon law of vector addition, there also we discussed these formulas, right? So then now if n number of forces are acting n number of forces are acting. Then remember, then for the equilibrium of the body, when a n number of forces are acting on that, E is given by the condition that is equal to 0 here. F1 plus F2, F3 plus so on, Fn is equal to 0 here. That will be the condition, right? And if you want to get any resultant here, Fn you want to get, then take the minus of these all sum of the individual concurrent forces acting on the body here. Okay, so this is a point related to the equilibrium of the body. I hope the points are clear, dear students. Yes, moving forward with the next concept, that is the common forces in mechanics. Common forces in mechanics. Yes, in the chapter 1 we discussed about the fundamental forces in the mechanics. That means the fundamental forces in the nature, right? How many are there? Totally 4 fundamental forces are there. What are those? The first one is a gravitational, second one is a electromagnetic, next is a strong nuclear, and the last one is a weak nuclear. Yes, and see, dear students, in the chapter 1 what we discussed is that all are the fundamental forces, right? But here now we are going to study the common forces in the mechanics. That means, as you know, the gravitational is the most important force which exists and which can play the vital role in the mechanics also. Because when we study the concept of the gravitation, there the point comes is a gravitational force. That movement of the planets and movement of the celestial bodies, and how the Kepler law is applicable, and when the planets are revolving around the sun, what force is existing, all will be explained with the help of the gravitational force only, right? So that is playing a vital role in the mechanics. But remember, gravitational is a non-contact force, because see, it is a body. Idan body aitrappa. ಈ ಕೈ ಬಿಟ್ವಿ ಅಂದ್ರೆ ಇದೇನಾಗ್ಬಿಡ್ತದೆ, ದಟ್ ಮೂವ್ಸ್ ಟುವರ್ಡ್ಸ್ ದ ಅರ್ತ್ ಓನ್ಲಿ, ರೈಟ್? ಹಾಗಿದ್ರೆ ಇವೆರಡರ ನಡುವೆ ಏನಾರ ಕಾಂಟ್ಯಾಕ್ಟ್ ಇತ್ತಾ? ದೇರ್ ಇಸ್ ನೋ ಕಾಂಟ್ಯಾಕ್ಟ್. ಆದ್ರೆ ಯಾವ ಫೋರ್ಸ್ ಈ ಬಾಡಿಯನ್ನ ತನ್ನ ಕಡೆಗೆ ಎಳಿತ್ರಿ? ದಟ್ ಈಸ್ ಎ ಗ್ರಾವಿಟೇಷನಲ್, ಗುರುತ್ವಾಕರ್ಷಣ ಶಕ್ತಿ. ಗುರುತ್ವಾಕರ್ಷಣೆ ಬಲ ಏನ್ ಮಾಡುತ್ತೆ? ಈ ವಸ್ತುವನ್ನ ತನ್ನ ಕಡೆಗೆ ಸೆಳೆದುಕೊಳ್ಳುತ್ತೆ. ಓಕೆ, ಸೊ ದೇರ್ ಫೋರ್ ದ gravitational force is called non-contact force. Is non-contact. And next, in order to understand the mechanics very clearly, here we need of the contact force. Whenever we are going with the study, in detail study of the mechanics, we need what? The contact force. Then tell me, what do you mean by contact force? Simple. The force exists between two bodies when they are in a contact each other. See here, between this chalk piece and the board, now there is a contact. Then between these two, what is there? Force will exist. And between this duster and the board, there is a contact, and then I am applying the force here, right? Such a force we call it as the contact force. Am I clear? The force between surfaces of the two bodies in a contact. Force between surfaces of two bodies in a contact is called contact force. Yes, and contact force is again classified into the two types. ಈ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಅನ್ನ ನಾವೇನ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ ಎರಡು ವಿಧವಾಗಿ ಕ್ಲಾಸಿಫೈ ಮಾಡ್ತೀವಿ. ವಾಟ್ ಆರ್ ದೋಸ್? ದ ಫಸ್ಟ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ಫೋರ್ಸ್ ಈಸ್ ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್. ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್. ಸೆಕೆಂಡ್ ಒನ್ ಈಸ್ ಫ್ರಿಕ್ಷನ್ ಆರ್ ಫೋರ್ಸ್ ಆಫ್ ಫ್ರಿಕ್ಷನ್. Yes, And let me explain you about the normal reaction. What happens in a normal reaction? Let us assume there are two bodies. Okay, call it is a body A, and this is a body B here, right? And when both the bodies are kept in a contact, you can see here, the body B exert the upward force on the body A, right? And according to the Newton's third law of motion, the body A also exert the force in the downward direction, isn't it? Or else, let us take another example here. Here is a one table, right? So on this table we have kept one book or any material you have kept, you can assume book or any material. Then see in this case what happened? Both book and table, the surface of the book and the table are in the contact, right? And here the book acts its weight in the downward direction, because so that is a weight of the book acting in the downward direction. At the same time, what happens? By the Newton's third law of the motion, the table also exert equal and opposite force on the book here. So that perpendicular, that force we call it as the normal reaction here. Okay, and this can be denoted either N or it is denoted by a letter R. Tell me what is a normal reaction? Simple. It is a component of the contact force, which is a component of the contact force act along the normal to the surface in a contact. ಇಲ್ಲಿ ನೋಡ್ರಪ್ಪ ಎರಡು ಸರ್ಫೇಸ್ಗಳು ಕಾಂಟ್ಯಾಕ್ಟ್ ದಲ್ಲಿ ಇದಾವು. ಹಾಗಿದ್ರೆ ಈ ನಾರ್ಮಲ್ ಗುಂಟ ಆಕ್ಟ್ ಆಗುವಂತ ಫೋರ್ಸ್ ಅನ್ನ ಏನಂತ ಕರಿತೀವ್ರಿ? ಅದನ್ನೇ ನಾರ್ಮಲ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಹೌದಾ? ಇದು ಸಿಂಪಲ್ ಡೆಫಿನಿಷನ್. The component of the contact force which act along the normal to the surfaces in a contact. This is a one definition. Then another definition is the perpendicular component of the contact force when two bodies kept in a contact is called the normal reaction, right? So I hope the point is clear. Then this normal reaction will be balanced, will be is equal to what? The weight of the body acting downward here. Therefore, when you take the total force when the object is at the rest, we can take that N minus W is equal to 0 here, then N is equal to what? W here, then it is nothing but N is equal to mg here. This formula we should know. That means the normal reaction will be is equal to weight of the body, and the weight of the body is equal to mass into acceleration due to gravity. Yes, the normal reaction is clear to all of you? Okay. Moving forward to the friction or the force of the friction. What is the friction or the force of friction? So this is also component of the contact force which acts along the horizontal, so between horizontal component or the horizontal line between the surfaces in a contact. Then if I want to express that, I can express here. The friction can be represented here. As I told, this will be a normal reaction, a perpendicular component which is acting upward, that is a normal reaction. And see here also between these two contact force one horizontal component is there, no? So that component only we call it as the friction or the force of the friction, right? Or else you can also state that the friction is the parallel component of the contact force between two bodies in contact. The parallel component of the contact force between two bodies in a contact. You can see here two bodies are in a contact, then its a parallel component we call it as the friction, right? So then it is called a force or a friction or force of the friction. Then this friction is always acting in a opposite direction to the motion of the body, because whenever the friction means friction will help also for the movement of the body, that we talk in the case of the study of the advantages and disadvantages of the friction, right? Now just we have one concept that the friction means we can also define as it is a tangential force which act in a opposite direction to the motion of the body. In other way we can also define that friction or the force of friction is the tangential force which acts in a direction opposite to the motion of the body. That is also called friction, right? Then friction is mainly classified into again two types. Yes, and see dear students, in your lower class ಇದೇ ಒಂದು ಪಾಯಿಂಟ್ ಅನ್ನ ಘರ್ಷಣೆ ಅಂತ ಹೇಳಿ ಕಲ್ತ್ ಬಂದಿರಪ್ಪಿ ನೀವು, ರೈಟ್? ಅದನ್ನೇ ನಾವೀಗ ಮಾತಾಡಕತ್ತಿದ್ದು. ಅಲ್ಲಿ ಕೇವಲ ಘರ್ಷಣೆ ಅಂದ್ರೆ ಏನು, ಅದು ಹೆಂಗ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ ಅದ್ರ ಬಗ್ಗೆ ಅಷ್ಟೇ ಕಲ್ತ್ ಬಂದಿರ, ಅದು ಯಾಕೆ ನಮಗ ಹೆಲ್ಪ್ ಮಾಡತ್ತ ನೋಡ್ರಪ್ಪಿ. ಬಹಳಷ್ಟು ಸತಿ ಮೊದಲಿಗೆ ನಾವು ಹೆಂಗ್ ಫೈರ್ ಹೆಂಗ್ ಪ್ರೊಡ್ಯೂಸ್ ಆಯ್ತು ಅಂದ್ರೆ ಡ್ಯೂ ಟು ದ ರಬ್ಬಿಂಗ್ ಆಫ್ ದ ಟೂ ಸ್ಟೋನ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. That is nothing but friction only. And now you can see in machine parts also, when there is a contact between two fast moving machines, the sparks will be produced. That is because of the friction only. Yes, then let us talk about the classification of the friction. One is a static friction, another one is kinetic friction. Stat means what? The bodies are at the rest only, right? Then static friction means the friction between the two bodies when they are at a rest. The friction between two bodies when they are at a rest, it is called static friction. Okay, static means remember that is a rest. So now see here, between this board and the wall there is a rest only, there is no motion of the board or the wall. Then between them also what happening, there is a friction, that only called as the static friction. And see, if I keep this duster on my hand, here also what happened, between the duster and the surface of my hand there is a friction, but the bodies both are at a rest only. When I start to move, then there is a change in the state of the body. Okay, so then when the bodies are at the rest, the friction between them we call it as the static friction, right? Then moving forward with the next concept, that is kinetic friction. What does it mean? The kinetic friction means the same. Kinetic means what? Motion. So when two bodies are in the motion, the friction between them is called as the kinetic friction, right? So here the motion will be there. That to what type motion? Relative motion. That means one body may be at the rest and another body is moving, or this body is at a rest and this body may be moving. Okay, like this, the friction between the two bodies when they are at the relative motion, then it is called kinetic friction. Okay, and see dear student, between static and kinetic, when a static friction is there and the kinetic friction is about to exist, by the time there is a maximum limit for the static friction. Actually the maximum limit may exist for the static friction here, then that maximum limit we call it as the limiting friction. What it is called? Limiting friction. Yes, and limiting friction can be represented as a Fs maximum. Here static friction means I can take it is a Fs, that is a static friction, and kinetic means Fk we can use, right? And here limiting friction means Fs maximum we can take. Then what does it means? Limiting friction means the maximum value of the static friction, the maximum value of the static friction for which or at which the body just tend to move over the surface of another body. The body tend to move so over the surface of another body, that we call as the limiting friction here, and that is why the maximum value of that is called the Fs maximum, represented by Fs maximum. I hope the points are clear, right? And after this value, when it crosses this limiting friction, which friction it will play? That plays the kinetic friction, because body will start to move only when a motion is present. Kinetic friction will be there. Yes, but kinetic friction again we can divide into two types. Kinetic friction, two types. One is a sliding friction, second a rolling friction. Slide means what? See, assume this is a slope, and here when I keep the object, it will slide over the surface of the another. Then between these two, what happened? There is a friction. The friction between the two bodies surface when one object slides over the surface of another. The friction between two bodies, or you can say kinetic friction, type of kinetic friction, when one body slides over the surface of another body, is called sliding friction. Okay. Then rolling friction means, you have seen the roller that is used for making the roads, isn't it? And that is a big roller only. If you come with the vehicles, the wheels only, there also cycle tubes, you can see tires of that vehicles, we can see that all are possessing which friction? Rolling friction only. Yes, the friction exists due to the rolling of one body over the surface of another body, right? But remember, dear students, here the sliding friction is greater than the rolling friction. Greater than rolling, because its magnitude will change here. Okay, or else you can say the rolling friction, magnitude of the rolling friction is less than that of the sliding friction. Yes, and therefore when we want to reduce the friction, we will convert the sliding friction into the rolling friction only. Because ನೋಡ್ರಪ್ಪಿ, ಇಲ್ಲಿ ನಾವು ಪಾಯಿಂಟ್ಸ್ ಗಳನ್ನ ಕಲಿತಾ ಹೋದಂಗ ನಿಮಗೆ ಅರ್ಥ ಆಗುತ್ತಾ ಏನಪ್ಪಾ ಅಂದ್ರೆ ಸ್ಲೈಡ್ ಆಗುದಂದ್ರೆ ಜರಿಯುದ್ರಿ. ಯಾವಾಗ ಒಂದು ವಸ್ತು ಇನ್ನೊಂದು ವಸ್ತುವಿನ ಮೇಲೆ ಜರಿಯುತ್ತಲ್ಲ, ಅವಾಗೂ ಅಲ್ಲೊಂದು ಫ್ರಿಕ್ಷನ್ ಅದ, ಅದನ್ನೇ ಸ್ಲೈಡಿಂಗ್ ಅಂತೀವಿ. ರೋಲ್ ಆಗುದಂದ್ರೆ ಗೊತ್ತದ, ಈಗ ನೋಡ್ರಪ್ಪ ಇದೊಂದು ಪ್ಲೇನ್ ಸರ್ಫೇಸ್, ಇದ್ರ ಮೇಲೆ ಒಂದು ರಿಂಗ್ ಅನ್ನ ಅದು ಇಟ್ವಿ ಅಂದ್ರೆ ಅದು ರೋಲ್ ಹಾಕೊಂತ ಹೋಗುತ್ತಲ್ಲ. ಸೊ ಅಥವಾ ಏನು ಬೇಡ, ನಾವು ಸೈಕಲ್ ಹೊಡಿಬೇಕಾದ್ರೆ ಅಲ್ಲಿರುವಂತ ಟ್ಯೂಬ್ ಸೈಕಲ್ ಟೈರ್ ಏನಾಗುತ್ತೆ, ರೋಲ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ ರೋಡ್ ಮೇಲೆ, ಅದನ್ನೇ ರೋಲಿಂಗ್ ಫ್ರಿಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಆದ್ರೆ ರೋಲಿಂಗ್ ಫ್ರಿಕ್ಷನ್ ಯಾವಾಗ್ಲೂ ಏನಿರುತ್ತೆ, ಕಡಿಮೆ ಇರುತ್ತೆ, ಸ್ಲೈಡಿಂಗ್ ಫ್ರಿಕ್ಷನ್ ಹೆಚ್ಚಿಗೆ ಇರುತ್ತೆ. ಓಕೆನಾ? ಸೊ ಹಾಗಿದ್ರ ಇಷ್ಟೊತ್ವರೆಗೂ ಅಪ್ ಟು ದ till now whatever the points we discussed, all the points I hope it is clear, right? And in today's session, what the points we discussed up to now, first related to the equilibrium of the body, there the three different cases we studied, and which law can be involved, that also studied. Then moved next in the common forces in the mechanics, and especially in that normal reaction, and about the friction we talked, right? Then now we started with the friction and its types, and in that static, kinetic, and again in the kinetic, sliding and rolling will be there. Yes, and actually so before this two more points are there, that in the common forces in the mechanics means two important, another important forces are there, that is tension in a string. Tension in a string, force due to spring. Tension in a string and force due to spring. Tension in a string means what? The string andre wire anta consider madbo. Assume this is a wire. there is a weight attached at one end of the wire. Then due to this weight, what happened? There is a small force exists in the wire, that only called tension in the string. In a musical instrument, due to that tension only we can play the musical instrument, such as a veena, sitar, like that. Okay. Then when you come with the force due to the spring, you have seen the spring. When a spring is compressed or extended, the restoring force is present. Due to that restoring force only, again the spring come back to its original state there, right? And that restoring force only we call as the force due to the spring here, right? And in the case of force due to the spring, if a force F is a force and X is the displacement, remember the force is directly proportional to the displacement here. But how it is depending? It is opposite to the direction. Because if you are applying the force in one direction, the displacement of the body is exactly opposite to the applied force. Therefore, in that we are using the negative sign. And when you use the is equal to symbol, here one constant should be used. That constant we call as the K only. Therefore, here it comes the restoring force or spring force F can be given as a minus K into X here, where X is a displacement of the spring and K is called spring constant. And F is called spring force. Am I clear? The negative sign just indicates that the force and the displacement are opposite to each other. Okay, dear students? So I hope you are understanding the points. Keep on studying and watching the videos. Thank you for watching my video.